Okay, hello everyone and welcome back to our YouTube channel. The lesson for today is rational exponents. Before we start with the lesson, I would like you all to have your copybook ready and a pen or pencil ready so that you can take notes and write the most important things down. Also, do not forget to, what everyone else does. Like the video, subscribe the channel because it's very important so that you can get actually all the previous videos and all the future videos that we will be sharing. Also, check in description. There must be a PDF with practice questions for your individual practice. All right, let us begin. So, as we said, the lesson for today, rational exponents. But before we start with the lesson, there is something very important that I'd like to remind you of. If we say, for example, we have a number to the power of m, and then there is another power to the power of n, we said the rule is multiply the exponents. So you would write your a down and then you would multiply m by n. So the answer will be a to the power of m times n. Let's have an example. 5 to the power of 3 and then to the power of 2. We said the rule is copy the base and then multiply the exponents. So 3 multiplied by 2 will be equal to 6. All right. I hope that that's clear. Now we can start with the lesson. When we have rational exponents, that basically means that we have some fractions in the power part. But before that, you remember how you learned in school that that is something that we call square root of a number. Square root of a number. Now we say square root, but we do not write any square. We do not write any number 2. Alright, if we say this is cube root of number 5. So there is number 3 on top of it. Which means, since this is a cube root and there is number 3, this is a square root. There is number 2 that we do not write. So there is no need to write it. We consider that there is number 2. So this is a square root. Alright, another important thing that we already know. What is the power of 5? So if we have 5 only, then it must be to the power of 1, right? Because 5 to the power of 1 is equal to 5. Now, the rational exponent rule says we copy the base, we have a fraction, and then the exponent of number 5 goes up. So it's 1, the root, the radical, it goes down. So the 2 goes down. So instead of square root of 5, we can actually write 5 to the power of 2. 5 to the power of 1 over 2. Same thing over here. It will be 5 to the power of, we said, what is the number of the exponent of 5? The one that we don't write. So we consider that there is 1, because 5 to the power of 1 is equal to 5. Now we write a fraction line. 1 goes up and this number here goes down. So 3 goes down. So it's the same if you write cube root of 5 or 5 to the power of 1 over 3. Okay, let us apply the rule now backwards. If we say, for example, any number to the power of 1 over n, for example, so we said that is basically n is our radical over here. So it's going to be nth root of number a to the power of 1. Nth root of a is equal to a to the power of 1 over n. Alright, let's have some practice on this. If we have, for example, 5 to the power of 1 over 4, then what did we just say? It will be 4 goes up, so this is 4th root of number 5. Excellent. But what if we have, let's say, 5 to the power of 2 over 3? Then what we do is we copy 5, we write the radical, and then number down goes here. So it's going to be cube root of 5 to the power of 2. All right. I hope that this is clear. Let us try now some other practice questions. If we have, for example, 16 to the power of 1 over 2. The logic that applies here is we write square root, we copy 16, and then we say the number down is our root. Oh, this is basically square root of 16. So what is the answer to this? Square root of 16 is equal to 4. So that means if we write 16 to the power of 1 over 2, that will be equal to 4. Good job. What if we say, for example, 16 to the power of 1 over 2? Now something very important. What can we do with number 16? Can I write 16 as 4 to the power of 2? So 16 can be written as 4 to the power of 2, right? Because 4 to the power of 2 is equal to 16. Now we copy the exponent from here. So that will be to the power of 1 over 2, right? Because we cannot forget 1 over 2. Guys, what did we revise in the beginning of the lesson? We said that if we have double exponents, we multiply the exponents. So it will be 4 to the power of 2 multiplied by 1 over 2. Oh, we remember the rule. We write it over 1. So this will be equal to 4 to the power of, don't we agree that 2 and 2 can be cancelled? So it's 4 to the power of 1. Oh, which is basically equal to 4. So 4 to the power of 1 is equal to 4. Now this part that we just completed here, this example will be very important, because using this example, we can solve so many different questions. If we have, for example, 125 to the power of 1 over 3. Now, just for a second, let's focus on number 125. How can we write this number? We notice that this is 5 times 5 times 5, right? Which means basically that is 5 to the power of 3. So instead of 125, we can write 5 to the power of 3. But don't forget, we have to copy this exponent over here. So this will be to the power of 1 over 3. Now, what we learned in the last lesson is we copy the number, and then since we have double exponents, we multiply the exponents. So we multiply 3 by 1 over 3. Oh, 3 and 3 goes away. It's 5 to the power of 1, which is equal to 5. So originally we had 125 to the power of 1 over 3. The final answer is 5. Okay, let's have more practice questions. If we have, let's say, 100 to the power of 2 over 5. Okay, what do we know about number 100? We know that 100 can be written as 10 to the power of 2, right? But don't forget, we have to the power of 2 over 5. All right, what will this be equal to? 10 to the power of 2 multiplied by 2 over 5, which is basically equal to 10 to the power of 4 over 5. That's it. We have it in simplest form. Or if we had a different example, 100 to the power of 5 over 2. So this one will be 100 can be written as 10 squared, but then don't forget to the power of 5 over 2, because we have to keep the exponent. Double exponents, we multiply them. So this will be 10 to the power of 2 multiplied by 5 over 2. Oh, what's this equal to? 2 and 2 goes away. This is 10 to the power of 5. So basically, 100 to the power of 5 over 2 can be written as 10 to the power of 5. All right, let's play more with this. This time we will have 32 to the power of 2 over 5. I will give you a couple of seconds. What you can do is pause the video and try to complete this. So what do we do when we have rational exponents? Try to do this one by yourself. Alright, if we pause the video and you have the answer, let us solve it here together and then you can compare if you have the same answer. 32, we know that can be written as 2 to the power of 5 because it's 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5. But then don't forget we copy the exponent, we copy 2 over 5. Now we remember the rule, double exponents, we multiply them. This will be 5 multiplied by 2 over 5. We know that 5 and 5 can be cancelled, so this is 2 to the power of 2, which is later on equal to 4. So if you want, you can say that this is basically equal to 4. So instead of 32 to the power of 2 over 5, you can say 4. Alright, I hope that this makes sense. Now, something that we learned in previous lesson, it's getting more difficult as you can see. Let's say we have a number 27 to the power of negative 4 over 3. What we learned in our previous lesson, if you haven't watched it, please go to the previous lesson afterwards to check this. We said that if we have a negative exponent, what we do is this number will be written, will be flipped. So basically instead of 27, we can write 1 over 27, but then our exponent becomes positive. So the exponent becomes positive 4 over 3. All right, what that means is 1 to the power of 4 over 3 remains the same. So this will be 1, but then we have 27 to the power of 4 over 3. Okay, we keep playing with this. 1 goes up. What can we do with number 27? It can be written as 3 to the power of 3, and then don't forget to the power of 4 over 3. Right? So we said double exponents, we would multiply the exponents. So it will be equal to 1 over 3 to the power of 3 multiplied by 4 over 3. 3 and 3 goes away, so it's 3 to the power of 4. The final answer will be 1 over 3 to the power of 4. You can then evaluate the value and you can say 1 over 3 to the power of 4 is 81. And that is the final answer to this question. All right. Let's try another example, probably a last one for today, or actually let's do 2 more examples. So 25 to the power of negative 3 over 2 and 9 to the power of positive 3 over 2. Again, we can do the same thing. Give it a try, pause the video, and then let me know in comments if we have the same answer. We will solve them here on the board. Let's try the easier one. So we know that number 9 can be written as 3 to the power of 2. Then we don't forget the exponent, we copy 3 over 2. We know the rule, double exponents, we multiply them. So when we multiply these two numbers, 2 and 2 goes away, it's 3 to the power of 3. If we want, we can find the value. 3 times 3 times 3 is 27. Okay, while in our numerator, since our exponent is negative, we only have to flip it and write it 1 over 25, and then the exponent becomes positive. All right, this will be 1 over. In the denominator, we have 25. We know that 25 can be written as 5 to the power of 2, and then don't forget to the power of 3 over 2. Again, we remember that 5, 2 and 2 can be cancelled, so it's 1 over 5 to the power of 3. 25 to the power of negative 3 over 2 is equal to 1 over 5 to the power of 3. Alright guys, I hope that was enough for today. So when we play with rational exponents, the idea is to simplify our base if it can be written as something different. So 25 can be written as 5 to the power of 2, and then we have our exponent. We multiply the exponents and we get the final answer. 9 can be written as 3 to the power of 2. If you multiply that by your exponent 3 over 2, it becomes 3 to the power of 3, which is equal to 27. Again, check the description box and find the PDF documents for you to practice and to master this topic. I will see you in the next video. Next we talk about standard form and scientific form.